Hey everybody, today we are getting into Geometry Basics 4, which would be dealing with angles. And we're going to approach angles sort of the same way that we approached segments and lines, rays, planes. We need to make some definitions. We need to get through. It'll be quick, and then we start doing some calculations. So let's start with what an angle actually is. I think you know an angle. I think you've seen an angle. It's not really that hard to identify. But what you need to know right now is that an angle is two rays with the same endpoint. So if you have two rays and they have the same endpoint, then they go opposite directions, maybe, which would make a line, or maybe they create a different measure of an angle. But I think you know pretty much what it looks like. There's even a picture of it down there. So each ray makes up one of the sides of an angle. And then the place where it all comes together is called the vertex. Now, the word vertex is where things come together a lot of times. You'll look at different shapes, and where two sides come together will be the vertex. So that word is going to come up quite a bit. Now, depending on your situation, there are three ways to name an angle. So one way is just by the endpoint. So it's probably better to just make a little sketch here. So I'm just going to say, okay, here you go. Here you go. And I think the easiest way to deal with this, I'm just going to call it angle ABC. Okay, there you go. That'll be one of our ways anyway. That's kind of a spoiler alert. I'm sorry. All right. So you've got A. Okay, you've got the endpoint, which we're going to call B. And then C. Now, if the picture only has one angle, then you're okay to just call it angle B. You don't have to go into further detail. You don't have to be more specific. So if there is only one angle that's coming from letter B, then you can pretty much look and just know, oh, that's the one that we're talking about. So in this particular example, angle B would be a perfectly acceptable name. Now, that being said, that's usually not how it goes. Usually, we try to get more specific. So we say, well, we're going to take a point on each side, and then we're going to put the vertex letter in the middle. So now, instead of calling it angle B, we are going to call it angle ABC. So that's the difference. Now, right now, neither name is wrong. Because, again, in this picture, there was only one angle coming from letter B. But if you want to be absolutely sure, it makes more sense to use three letters. Now, the other thing is sometimes they just give you a number. Sometimes they just refer to it as, they'll put a little mark there, and they'll just put, 1. Or maybe they'll just sneak a little number 1 right there. And then at that point, you would just refer to it as angle 1. All right. Now, if you remember the previous lesson, it talked about the ruler postulate, basically saying somebody a long time ago decided, hey, I'm going to take this stick, I'm going to put markings on it, I'm going to designate it with numbers, and we are going to use this to measure things. Or in the case of a number line, I'm going to put numbers on this number line, and those are going to be my coordinates. That's exactly what's happening with angles as well. Somebody decided, hey, we should measure these. We should be able to come up with a way to measure how open or how closed an angle happens to be. We use protractors for that now. The thing on the right is a protractor, so it makes sense that the rule that we are dealing with right now is the protractor postulate. Okay? Now, the measure of angle AOB on the right, okay, so if you look, we've got, I'm going to put an O right here. O is a lot of times, if we do use that as a letter, we use it to describe kind of the middle, the origin. Sometimes you'll see it with a label like that with a 0 or an O kind of looking thing. So just throwing that out there. And then we make a new point A. Okay, so this is the example that we're working with in the postulate. Now, it asks what is the measure of AOB to the right. And so to give yourself some perspective, I want to just throw that up there. You know what a right angle is because you've probably seen it a million times before. This angle is open more than that. Therefore, it is bigger than 90. So when we're measuring, we want to use the bottom numbers on the protractor here, and we want to say that the measure of angle AOB to the right is 130 degrees. All right, now, real quick, we've got different types of angles. So let's start with a super easy one. If your angle is fairly small, it is going to be a cute little angle. That was how I was always taught. Oh, it's a cute little angle, and that helps us remember that it's an acute angle. Super cheesy, but I'm sorry, it's all super cheesy. All right, now, I just went over the next example with you where if it makes a 90-degree angle exactly, that's going to be a right angle. That's another one that you knew. I know that you knew that. Even though I can't actually see you right now, you knew that. All right, now the example above here, let's save ourselves some time. Let's just take the example from above and just copy and paste. That sounds good to me. That's totally cheating, but that's okay. There you go. All right, we already used that one. That is an obtuse angle because it is more than 90 degrees. Now, the one that you might not be terribly familiar with is what if you have opposite rays? Okay, so you've got opposite rays going on here. So let's say that they both come together in the middle. So let's say we've got point R right here, and then you've got Q here, and then you've got S here. So these are opposite rays. Opposite rays make a line. So you've got RQ going to the left, you've got RS going to the right. Now, when it comes to this, it is not acute, it is not right, it is not obtuse, it is actually just straight. And just for the record, a straight angle is really just sort of two right angles put together, added together, 90 and 90, which would be 180 degrees. All right, so let's get to the angle addition postulate. If it seems like I go through this quickly, it's because it resembles exactly what we did yesterday with segments. If you didn't catch the previous video, the Basics 3 video, you can go ahead and do that. If not, that's okay too. But let's say you've got angle A, and then you've got the middle, and then you've got C. And let's say we put a new point in the interior. Now, interior would just mean inside. So anything on the inside of that angle, so I'm just going to say right there. Okay, and I'm going to make a new ray. Now, again, this is a situation where you need to be more specific with your naming of the angles. The reason being now, there's more than one angle in the picture. So if you just say angle O, that's not good enough because there are multiple angles coming from O. In fact, there's this little guy, there's this little guy, and then there's the entire thing. So you've actually got a lot of options here. So the angle addition postulate just says that whatever measure this is plus whatever measure this is, and we know they're not necessarily the same, so I'll give them different markings. I'll put 2 loops on that one there. The part plus the part equals the measure of the whole thing. Very, very similar to what we did yesterday, so that should be fairly familiar. All right, so we're going to do a little bit of practice here. And for all the problems, we assume point Z is on the interior. Okay, so I think we could probably get away with only doing this drawing one time. If that's not the case, maybe I'll have to draw it again, but I think we'll be all right. So just one time on your paper, I just want you to draw. And it says Z is in the interior of WXY. So first, I'm going to make W. Then I'm going to make X and Y, and I'm going to put Z on the interior. So WXY, and I'm going to put Z on the interior. Now, what that means, since these problems all have different numbers, this drawing will not be to scale. But that's okay. All right, example number 1. WXZ, you kind of follow along with your finger, is 37. ZXY is 45. What is WXY? So they give you the part and the part. You need to know the whole thing. Well, we know the part plus the part equals the whole. So instead of setting up a crazy equation or anything like that, I'm just going to add 37 and 45. And I am going to say that the measure of angle WXY is 82 degrees, 37 plus 45. So there you go. All right. Question number 2. Now, what would happen if WXZ is 41, but now the whole thing, WXY, is 90? So now we're going to say 41 plus the other part. So again, we're doing part plus the part equals the whole. Now, if you've got a lot of math common sense, you probably already knew, oh, if they give me the whole thing, I'll just subtract. That's great. You're right. Do it. I'm demonstrating it this way so you can actually see what's going on. If you have to actually solve the equation, it would be a one-step equation. You would subtract from both sides, and you would just find out that x equals 49. Now, as I have been repeating over and over and over again with my kids when I see them, that is not actually an acceptable answer. You can't just say, oh, the answer is x equals 49. It was asking you, what is the measure of angle ZXY? So you need to be specific. You need to actually say, oh, the measure of angle ZXY is 49 degrees. That's what that M means. When you see that M in front, that's a measurement. It's basically, what is the measure? How big or how small is the angle? All right. WXY is a right angle. And then they break it down into two parts. So we're going to say the part plus the part equals the whole thing. So 2x plus 7 plus x plus 11 equals, well, we know it's a right angle. So the total would have to be 90. So we combine our like terms and we get 3x plus 18 equals 90. We add up the 2x and the x, we get 3x. We add up 7 and 11, we get 18. Then we subtract 18 from both sides. You can do that part on your own. You can pause the video if you need to, but I'm just going to go through because I want to make sure we keep this pretty short. And then if 3x equals 72, then our last step would be to divide by 3. You'd get x equals 24. Now, so x equals 24. That doesn't actually answer the question for us. It said list all 3 angle measures. So now we are expected to actually list them. Maybe on the side here would be fine. All right, so on the side here, you're going to want to write WXZ is, well, now we got to plug in that number. X is 24. 2 times 24 is 48, plus 7 is 55 degrees. ZXY, we plug in 24 again. 24 plus 11 is 35 degrees. And then we already knew that WXY was a right angle, so that would be 90 degrees. All right, let's do this last one. WXY is a straight angle. So this one I'm going to have to draw again because it's going to be a little bit weirder looking. WXY is a straight angle. Now, I already brought this up. If an angle is a straight angle, it is 180 degrees. WXZ is 3 times bigger than ZXY. So I'm going to throw Z way up here, and then I am going to connect them like that. 3 times bigger. So I don't know what the little guy is, but I know the other one is 3 times bigger. So here's what it comes down to. If the little guy is X degrees, I don't know what either of them are, but if the little guy is X and the other one is 3 times bigger, then that's going to be 3X. There you go. So when you do the part plus the part equals the whole, you're going to say 3x plus x equals 180. So the big part is 3 times bigger. So instead of calling it x, we're going to call it 3x. Now from here, once you have the setup to these problems, it's usually actually pretty easy. You combine like terms, divide by 4, x is 45. So now the last thing you have to do, it did say at the end you have to list all 3 angle measures. So that's what we're going to do here. I'm going to run out of room, so I'll just scroll down just a little bit more. So WXZ is going to be the big guy. If it's 3 times bigger and x is 45, 45 times 3 is 135 degrees. The little guy was just x, so that's 45 degrees. And then the whole thing would be the straight angle, which was 180 degrees. All right, I hope this helps out, and I'll see you next time.